Hey everybody, this is Larry. This is day 13th of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Didn't do so hot on the contest earlier today, so I think the fastest finally, I don't know. Well, I just ate recently, so right now I'm a happy boy, but man, that contest, I had some like clear brain fog of just silly I don't know, just silly mistakes. A lot of weird things and that was a contest where, and I don't mean it in a bragging way, but I feel like if things kind of got a little lucky and worked my way, I probably could have been top 10. But I think I was just like, there's a couple of places where I misread things, there are a couple of places where I made silly mistakes, and there are a couple of places where I just couldn't see it. It is what it is. And then as soon as I saw it, I was like, oh yeah, this is Larry, you're silly. But anyway, anyway, let's see what the problem is. 2369. Check if there's a valid petition for the array. All right, so you have a. This is also a recent contest problem. I'm just guessing because of the problem number. But anyway, you have a petition array into one or more contiguous subarrays. You call it valid if one of the following conditions. You have two exact elements, okay? Or two elements that are equal, okay. If there are three elements, they're also equal. Okay. Three consecutive increasing. Okay. It's untrue if the array has at least one valid partition. Otherwise, return true. Yeah, I mean, I think this is just dynamic programming. The first thing I was going to do was just checking for bounds. To be honest, my first inclination was still gonna be dynamic programming, but the divide and conquer, like, when you talk about partition, the thing that comes to my mind is just like breaking in the middle. And I was gonna do something like n cube, like, you have the left and right, and then given a certain sub array, is there a partition, right? But then, and right after that, to be also like, even before I look at the constraints, to be honest, but I was like, I think there is an optimization here, but and that is basically a sort of a connected component. Is there basically you can think about it as a graph problem, and when you think about it as a graph problem, and this comes in dynamic programming as well. If that is the case, then you go, okay, well, the nodes are the space in between the number, and then the edges are if these things make a valid partition or valid subarray. I don't know whatever the terminology is, right? And then basically you have all these like hops for edges, and then the idea is then whether you can go from left to the right or the other way around. This one again is symmetric, so it doesn't matter. Yeah, and it's connected in that way. And yeah, I guess you could do like, if you're really funky, you probably could do like Union Find or something like that. But just based off that idea, right? Just looking at edges, but that's not even necessary because that's the same for loop. It's just that you're using a different data structure, right? So so I usually do these, very I think I've been doing these dynamic programming problems the same way the last couple of days. So maybe I'm gonna. So what I was thinking of is actually spicing it up a little bit. The way that I usually. So the reason why I usually teach top down, to be honest, is because I want people, and maybe this is just me. Like I said, I think most people should be proficient. If this is your goal of getting better competitive, getting better at interviews, maybe that one I'm not so sure on. It's important that you get proficient with both. But I like to teach top down because for the more beginners, I like to kind of get that focus with recursion, right? And recursion has, maybe dynamic programming, you could say maybe it doesn't have as much applications. Memorization comes up a lot in real life. You just call it caching. But recursion also just comes in randomly, and there are a lot of recursive structures, right? You wouldn't necessarily do them in real life for performance reasons, depending on but depends on what you're doing, right? But in any case, all that said, yeah, I'm just going to do this with basically optimization in my head, and we'll go over it, but hopefully this is still understandable, right? So basically, the idea is that okay, and maybe another. I don't know. I haven't had much practice explaining this in a while, but the idea then in this case is that for every node, like I said, every node, if the next two elements, the node is the space between the space between two numbers, right? So let's say we have something like this. I'm just copying and pasting, right? And the nodes would be where I draw the stars, and maybe I need whiteboard, and then you could draw edges with the there's an edge between these two nodes. Too much ASCII art. And then there's an edge between these two nodes because 444 is good, right? And then, like I said, it's just about connected components or whatever, or connectivity, whatever, from the first node to the last node, right? I actually forgot to draw the last node. Whoops. From the last node here. So that's basically the idea, and the way that I like to do it is with a for loop, naturally, to be honest, because it's very easy to kind of see, because way off. I mean, so the way that I like to think about it. So what is the difference between memorization or top down versus bottom up, right? The thing about top down for me is more intuitive to teachers because the idea to explain the idea is that we have a node before. What is the answer for this node? Well, the answer for this node is just a function of other stuff that is, you go out and get it, right? Like I need things for this. For this, I have these requirements, and then you go out and get it. Almost like a topological sort kind of thing, right? And in a way, if you look at the recursion tree of top-down recursion, and memorization and a topological sort, you probably see a lot of similarity there, except for maybe I don't know, right? Except for you can think about it as a dependency graph in a way, right? Because you're like, okay, I need the node answer for this node, and it requires this answer for this other node, and this answer for the other node, and so forth. So using that analogy, bottoms up is also similar in that. It is also like topological sort, but the queue-based version, right? Where instead of saying, okay, I need the answer for this, and this means that I need the answer for this other thing, and this other thing, and this other thing. Bottoms up is basically saying, when I get to this node, I know where to get the answer, and all the answers are already done for me, right? So that's basically the idea about this, right? It's like and the analogy for topological sort in that one, it's kind of like, okay, right now I ask myself, what class can I take? The course schedule or whatever it is, topological sort. What class can I take? What class has no more prerequisites? And in that way, bottoms-up dynamic programming also has that kind of thing where you're like, okay, what node right now can be processed because it has no more requirements that are unfulfilled, right? So that's bottoms-up dynamic programming. I don't know that I'm probably not unique, but I don't think that the way that I explain it comes up that often. So maybe this will kind of be a new perspective for people at home and for doing bottoms-up. So yeah, so in this particular and in certain problems, it's easier to do one or the other. In this one, I think it's a little bit easier because by the time I look at this node, I could look at the previous node and I know that they'll be done already because all you do is scanning left to right. So I could write something like and to be honest, originally I was gonna write this as I was gonna already do the space optimization, but we'll do the space optimization. But I'll just do I feel like I'm too deep, so I'll just do the regular bottoms up for now, right? So then now we can, and you often see people like write something like I will best maybe DP something like times n or something like this, where n is equal to length of nums, and technically this is n plus 1 because there are n plus 1 nodes given n numbers, right? But actually, I don't even necessarily want to write this way, because the way that I want to write it for today is though for memory considerations and stuff like that, and especially in some languages, you actually do want to allocate all the memory up front just because it's more efficient actually. But I just want to illustrate the idea, right? So the idea here is that now for I in range of n, and keeping in mind that this I and this n is kind of different from the DPI, right? What I mean by that is that this I represents the ith number 0 index of nums, right? And so when you get off by ones, this is the part. I mean, I put it's a little bit of a pedantry, but the reason is because I want you to be very precise in the difference, right? Because the ith number is not the same as the ith node. I mean, it may be in this case, maybe I think it actually is, but they're not the same, right? Because we're talking about these are the nodes and these are the numbers. So in a way, the numbers are given the things that composes of possibly an edge, right? So then now, what happens, right? So let's say we have current, right? So we're current node, and what does this mean? Let's say we have this node. This is the current node. That means that we want to go. Let's say this is the node, right? Then what happens? Well, we have to look at this number and this number for the two equal element part. So basically, this is equal to. Let's just start out with force, because by default it is going to be force. That's like the base. And then here, it's going to be, let's just say I is greater or, okay, so let's say we're on this node, right? What is this node? Well, this node is going to, this is, maybe the way that I phrase it is still a little bit awkward. But okay, let's actually change this a little bit. I mean, despite what I said, let's make I the ith nodes, right? So we start at 1 and we end at n plus 1 because this is the first node that we're going to process, because we already have the first node, which is this is 0, and also this isn't 0. This is true because you can go from 0 to 0. And here, what we want to define dp as dp sub I is equal to whether we can reach the ith node, keeping in mind that again node is the space in between two numbers, right? So then here the ith node, maybe that's a little bit clearer, right? And then now we want to say c, right? So what does this mean? Means that if this is I equal to 2 because we need two numbers, right? So then now if I is equal to 1, then nothing really happens. But we'll skip to I equals to 1 for now. Let's say, and maybe we should just skip it then. No, we need it for a reason. I forgot that we need it. But I mean, you can make it a base case, but it's fine. It's a very minor optimization. We don't need to do it. But let's say we're here, right? Then now we go, okay, there are definitely two numbers in between the previous. There exists a possibility that that's true. And okay, so what does that mean? That means that this is one of the number, and that's of course I is equal to 1, and this is I is equal to 0. So that means that when I is equal to 2, we look at the number where the index is 1 and the index is 0, right? So that means that we make sure that this is 2, and num sub I minus 1 is equal to num sub I minus 2, right? Yeah, and that's just basically saying this is 2, this is, and the mapping is because, for the number before the ith node is num sub I, right? I minus 1, right? So that's basically the reason. I wanted to kind of say it this way. And this is an or equal to. So we also do the same for, I do actually, I think there's early termination here, right? But maybe I don't know. Right, so same idea here. I'm not gonna, you know, just repeat the same thing. And then, what is the last one? 3 consecutive increasing. Oh, and the adjacent element is 1. Okay, so same idea, right? Maybe I could write that in one line. I don't know, right? And then now we can append dp, right? Up here. Oh, I messed this up, didn't I? So yeah, I did. Whoops, sorry. I've been focused on kind of just writing it out. Also, it was too long, and just this part. The part is that this is the case, and that we can get from the previous node, right? So that means, so this part is saying that there's an edge, like for example, from here to here, or here to here. But it has to be that this node is reachable first, so you have to actually do n dp of I minus 2, right? I mean, minor fix. After effects of fasting. That's my excuse, I'm sticking to it. And then yeah, and then now we can just do the last element, which is n minus 1, right? And I'm wrong. Dong dong dong. Dong dong dong. Probably did something silly. Let's see. Let's take a look. True. Do I went off by 1? No, that should be good. Oh, I'm just being dumb. The reason why this is false is because this is not inclusive. So we just missed doing the last node. This is, I don't like this is why I like certain languages where you could get equal to less than, because then now you don't get any confusion about it. Yeah. Huh, did I mess this up? No, oh, no, this is right, actually, my fault. This is the last one, but then what, did I mess this up? Oh, what did I just have a typo here, that's why. Well, maybe other stuff as well. Man, this is shaping up to be I'm just double checking my code a bit. Oh. Now we have to return the last element, which is actually dp of n. I got a little confused because I usually write it as dp negative 1, but then I was like trying. Okay, yeah, because the last element is actually dp of n. Maybe negative 1 is cleaner. But yeah, I don't know why I'm struggling that much today. But yeah, that's pretty much it. So the key thing about the optimization is that the space optimization is that, you know, noticing we ever only care about 3 elements here, right? dp I minus 2, dp I minus 3, dp I minus 3. So you can actually just keep them as variables. The way that there are a couple of ways you can write this. You can maybe right now I don't know. You can write this as like A B C D or ABC or whatever, and then just kind of you know, is you go to BC current or something like this at the end, and then just kind of rotate 3 variables is my point, and then, you know, substitute them here in a more precise way. I think that's the way that I would do it. I'm not going to do it now because I don't know. I feel like maybe today I'm still getting my marbles back. So yeah, that's all I have for today. But definitely do the space optimization thing if you have a chance. But I hope this kind of gave you a new way to think about bottom-up dynamic programming, especially if you struggle with it. I do get a lot of questions about why I don't explain it this way more. To be honest, I just feel like it's harder for beginners, and definitely you can, you know, consider doing it. But yeah, that's all I have for this one. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.